I'm Nathaniel.
I'm Antoinette.
And I'm April.
Our group will be focusing on the topic of subtraction and addition.
Targeted at a Year 2 level.
To addition and subtraction are that they are used to represent and solve many different kinds of problems, which will be unfolded throughout the presentation. These can be done in various ways, such as number lines, diagrams, and drawing pictures. I'm going to talk about John Dewey's learning by doing theory. The reason why I'm going to be talking about his theory is because it is essential to learning addition and subtraction through a hands-on approach, which we feel is essential to learning at such a young age. Students need to see things physically, and John Dewey's learning by doing theory really allows you to do this. It allows you to learn through experience and to learn by being physically active and seeing it in your own way. Okay, when students see this equation, 8 take away 3, it can easily be done like this. We've got 8 paddle pop sticks, and we can physically take away 3 paddle pop sticks with the result of 5 paddle pop sticks left. However, some students interpret this equation like this. This is where the paddle pop sticks come in handy, so we can physically show the students that you cannot take away 8 paddle pop sticks away from 3 without getting a negative result. This misconception was handled by taking Dewey's learning by doing theory and putting it into practice. The misconception was handled in this way so that the student could physically see that 3 could be taken away from 8, but 8 could not be taken away from 3. Another misconception for addition and subtraction is misapplying the place value of digits when writing the rule. The main misconception that grade 2 students have is thinking that subtraction is commutative. I chose to tackle this misconception in the following way to connect to the key idea that was mentioned earlier about encouraging students to record their thinking and working out. Okay, so the way to get over these misconceptions is to go right from the start, and this involves writing up a place value chart. So we're going to go hundreds, tens, and units. We'll stick with the same equation as before. We had 13 take away 8. There is one lot of tens in 13, which means we put 1 in the tens column and then 3 with 3 units, meaning 13 altogether. And then we've got 8 units. We're going to break this up even further, and we're going to put this into a diagram. Here we have a tens chart. We need the kids to trust the tens chart and to understand that there will always be 10 in that, unless shaded otherwise. We're going to do another one because it goes over 10 into 13. Here we have 13. Now we're going to do one more. So this one down here. And only shading 8. Now, based on the diagram, the way we can do this is physically take 8 away from the diagram. We can go 1, 2, 3, 4, 5, 6, 7, 8, and know that there is 5 left. So based on the diagram, there is 5 left. However, going over to the rule, this is where people get very confused. We know that you can't take 3 away from 8. So what we need to do is take a group from the 10, so that now we'll change into 0 tens because we've just taken a lot of 10 and put it into the units. That now means that there is 13 units, take away 8, and we know we can do that now because that equals 5. Done.
Good.
The way this can be done on a number line is as follows. First thing we want to do is draw up our number line. Then we want to know our equation. Our equation for today is going to be 13 plus 27. At the start of the number line, we know it's 0. We want to first get to 13 and then make our way to 27. So, this is going to be moving up 10 spots, so we know that's 10. This is going to be 3, which equals 10 and 3 is 13. We now want to add another 27 and see what it is altogether. So we're going to add another 10, another 10, extending our number line. A 5 and a 2. Then what we're going to do is add all of these together. So we've got 10, 3, 10, 10, 5 and 2. We still want to keep our place value in mind. We know this is a tens column and this is a units column. So now we're going to add all of these up. We know 3 and 5 is 8 plus another 2 is 10. So we're going to place a 0 here and we're going to put the 1 in the tens column. Now we have 1, 2, 3, we have 4 lots of 10, which means it equals 40. Another way we can do this is by, again on the number line, but this time we're going to be fast tracking. So we start at 13 and we just go up to 27. So here's your 10, another 10, a 5, and a 2. So then we go 13 plus 10 plus 10 plus 5 plus 2. Still keeping in mind our place value. So we have our tens and our units. 5 and 3, again, equals 8 plus 2 is 0. And then we're going to put our 1 lot of 10 in the tens column. Then we have 1, 2, 3, 4 lots of 10, which equals 40. And we get the same response as we did over there.
As did Wall, K. Williams and Karp suggest, for the purpose of this activity, we're going to be using the 3-phase lesson plan. So basically it's activating the students' prior knowledge, letting the students work, and then coming back together as a whole class for a discussion and reflection on what they've learned. So you as the teacher can see what students have got the information that you wanted them to get out of the lesson and who maybe hasn't made as many connections as you were hoping. The overview of this lesson is one where you would have a teacher-directed element at the beginning of the lesson, followed by students practicing the new skill, and the teacher walking around and observing the children practicing the skill, and then a reflection and discussion upon what the students have learned through the lesson. The prior knowledge students will need to be able to complete this activity is to be able to represent, solve simple addition problems using strategies such as counting on, recognise, model, organise and write numbers up to 100, as well as being able to place numbers 0 to 100 on an accurate number line. The learning objectives that we are focusing on in this lesson is for students to be able to explore the connection between addition and subtraction, ACMNA 029 of the Ausvels. Particularly focusing on using counting on to identify the missing element in an additive problem. We chose this activity because it's easily adapted to students of any level in the classroom, whether you have students that are already up to thinking multiplicatively or students that are still using hands to count on. So yeah, it's just a really great game. So to activate students' prior knowledge, I would probably ask a question such as, so yesterday when we were doing maths, do you remember that we were doing addition and subtraction? So problems that look like this. So who can help me do this? Posing questions to the class gets them involved and also allows you to see that they still remember what you were trying to teach them yesterday. Going through this, so the students would answer, you'd have a discussion, maybe possibly do a few more depending on how actively listening the kids were. Then you'd move on to what you wanted to teach them in this lesson, which, as we've already discussed previously, is the missing add-on. So once you've done a few simple addition problems with the class, I would introduce missing add-on as, so if I have a problem that's 3 plus 6 equals what? We can all work that out because we're all really clever. But what happens if I don't have all the information? So if I had a piece of paper and I really needed to solve this addition sum to be really, really clever, what if I had 3 plus equals 9? What would I do? Would I just give up and go home? Who thinks that we could actually solve this? This gets the students thinking, what does happen if I don't have all the information in the correct order? I would then pose the questions to the kids, how do you think we would start to look at this? So if you know you have 9 and you had 3 originally, how many more would I need to get to 9? For this stage, I would possibly use counters so that they can see and put a pile of 3 and a pile of 9 and ask how many more counters. Introducing language such as how many more gives students more of a vocabulary into mathematics. This will help them in later years when problems become more difficult and more word-based.
Students will be split into teams of 2 to 4. Anything larger than this may not work as effectively. Students will be given a deck of cards and it'll be split, numbers 2 to 5 and then 6 and above. Students will split the deck, having the largest and the smallest. So we'll start. So an example would be 5, whatever the missing add end, 7. So 5 plus what will give you 7. Students will work out what that plus will be, that being 2. So 5 plus 2 will give you 7.
The teacher may also choose to extend students by including subtraction and moving students on to seeing multiplication as repeated addition.
The reason we have chosen to do this activity in groups of 2 to 4 is because, according to Mazzano's cooperative learning ideas, grouping students into informal groups allows for different perspectives on the task, and thus collaborating all prior knowledge into a successful completion of the task. Informal groups are generally characterized by groups of 3 to 4 students randomly assigned as opposed to assigned by their ability or gender. If students are constantly grouped based on their educational abilities, there would be no allowance for advancement for those students who struggle. This is due to the lack of challenge that is experienced by students. If student groups incorporated both higher and lower students, it would allow for students to develop their educational abilities much further than they would when grouped based purely on ability.
The teacher may also choose to extend students by including subtraction and moving students on to seeing multiplication as repeated addition.